All right. All right. Today we're going to start a series of things. So I've got a couple of updates for the printer that we've been building. We had a clog over the weekend, so I thought it might be a good idea to show you how to fix a clog. I have fixed this one, so we'll have to kind of fix it, I suppose, but I saved some of the pieces that I had to pull out of the nozzle just to show you what can happen to a printer that can lead to some weird results. You're not sure what's wrong, and we can, in this case, fix it. We're also going to start a finishing series. Now, this one I'm going to have to break into several different pieces because, well, a lot of the steps, you know, they take time for paint to dry or things like that, and so I don't want to just sit here literally watching paint dry. So we'll do some, and then we'll wait till the next time and pick it up again. So it'll occur over several different episodes consecutively, or maybe not even consecutively, I don't know. But anyway, first let's get into a couple of things. Let's get into that clog. Let me go ahead and turn the printer on over here, so because one of the things we're going to need to do is heat up the nozzle to deal with this. So let me show you. First of all, I noticed it was a clog because I couldn't get prints to come out evenly. Everything was either way too over extruded, I was having to heat it up too hot, and things were just kind of wavy and bubbly when it was printing, or nothing would come out at all. So I did what's called a cold pull. So I'll show you what that does in a minute. But it did basically something like this. Let's zoom in. It's a little piece that came out of there. So I was printing with some silver filament, this color filament, and we'll show a cold pull, but to describe it, basically you heat the nozzle up to where this is actually down in the hot end down here, and so you heat it up to the point where it is going to melt. So whatever temperature this would melt at, so or at least melt to be extruded, and then you let the nozzle cool back down. In this case, around so I heated this up to, I think it was around 215 maybe, just to make sure that it was not something wrong with the filament. Then I let it cool down to 90, and when it got to 90, I just literally pulled the filament out. Now in this case, it's the filament and the Bowden tube, so it's a little bit more cumbersome to do because we're on the Ender 3, and you have that Bowden, and a lot of printers have that Bowden tube also, not just the Ender 3, but you have to pull both of them at the same time. Or either you have to figure out how to get both of those out of there. And this came out, so that looked good. It looked like, well, it got everything out of there, but it still was. I switched back over to our brown filament, you know, this stuff that we'd been printing with, and I just couldn't get the brown to work, and it just wouldn't print very well. So I did another pull with the brown filament, and this came out this time. So this one, I don't know how well it shows up on there, but it has the silver all mixed in there, and the part that's in the nozzle it was actually folded over. You can kind of see there how it's folded over there. So it was, you know, there was just clearly something in the nozzle itself. So then I decided it was time for a little more effort than a cold pull. And so I took apart the nozzle. So let's move you over to the printer here. Also, things are a little bit dark in here today. I'm working in the shop, and half of the lights are currently disabled right now. So maybe next time they'll be back running. But let's get over here to where we can see the nozzle. Now, I've changed a few things on the nozzle. On the hot end as general, not the nozzle itself. So this, actually we're zoomed in, aren't we? There we go. So all of this back here, that's part of another project that we're working on here. And for it's a quick release. So I can actually take the whole thing off of here and put a new item on. So I've got two other things currently. We'll get to those at some point later in the course. But one of them is, now I could put in a motor with a drill on it. So now I can do a little bit of engraving. Now you can't really do a whole lot of CNC stuff because of the side loads, but what I plan to do is engrave on this stuff. This is copper clad, so it's basically a piece of fiberglass with a thin layer of copper over the top of it. You use it to make little circuit board type things. Not this one, this is one that goes with the motor, but it's a speed controller for the motor. But I thought that we could handle the side loads necessary to engrave on copper clad, and I saw some other people who had done that. I've never actually done that with a 3D printer, so I thought, you know, this motor I got off of Amazon for like $10, so I figured it's worth trying to see how well that works. But I didn't want to constantly have to unbolt things and bolt other things, so I found this quick release. This part of it, you know, this part was already made. I'll link to where I found that. It's just on Thingiverse. So I printed that out. It works really well. There's no wobble in here. I just printed it in PLA. And I have printed a couple of times on the printer since then, and it has done fine. There hasn't been any melting or anything. But in general, as long as your cooling fan on your hot end is cooling the heat sink side of the hot end, you shouldn't have anywhere on the printer that's hot except for that block and nozzle, the actual heating block and the nozzle, which so far has held up and hadn't had any problems. I also went ahead and, I don't know if you remember last time, but I brought out the Bebo printer, and I said that it had a laser with it that I'd never used, so I made a little mount for, now we can put the laser on here and do some laser engraving. Now, it's not a powerful enough laser to actually cut very much other than maybe cardstock or whatever, but put that on there. I don't know exactly if I want to do that without some kind of enclosure yet, but at least now I have a way to quickly attach it. This laser also for the Bebo 3D printer doesn't easily attach. You have to do some disassembling to get it to attach. But with our quick change, we can put anything we want on here. And I made a little mount up here to hold the hot end out of the way, because I didn't want to disconnect everything from it. And so I made a little place to hold it out of the way. So that's what all of that is. So we can put this guy back. Also, it makes it really nice to get in here and work on stuff while it's still connected without having to disassemble everything, if you want to. All right, so the clog. Let me move this up. All right. So the clog, what I had to do, let's get way down. Oh, how am I going to turn this? Let's see, we're going to have to, maybe I just need to raise this up higher, because we need to see the nozzle. Now we're probably getting close. Oh, you can barely see it in there. Let's see. Trying to figure out how I can make this camera do. There it is. All right. And I think we can actually get it to, it's not hot right now. Focus on that guy. All right. So the nozzle's right here, and actually it's got some stuff on it. So what you do is you need to heat up the nozzle. You don't ever want to try and remove one of these nozzles while it's cold, because the metal of the nozzle and the metal of the heater block that it's screwed into both expand when they get heated, and it's almost impossible to remove them cold. But when they're heated, then they expand at different rates of different materials. One's brass and one's aluminum, and so they actually make it easier to remove when they're hot. When they're cold, it's almost impossible without breaking something. All right, so I just went over to the menu over here and told it to heat up the nozzle for PLA. This fan duct is going to be in our way to get to the nozzle, so I do need to remove that. And let's see if I can find the right size. Well, can't pick up the right one. It's a tiny one. All right, here we go. We just need to get it out of the way. We could take the whole side off here, but we don't really need to do that. I guess we could take the whole cover off if we really wanted to, but again, I I don't want to do all that just to get the nozzle out. If you haven't replaced this, then the stock fan duct here isn't in your way as much, and you probably don't even have to remove it to do what I'm going to do. But for what I need to do, this one does get in the way. You can also see that we're starting to get a little bit, it's kind of blurry, that starting to get a little bit of melting on the tips of this thing, particularly right there. Again, that one's just in PLA, so it's going to be tough to last forever, but it was easy to print, so we can make another one if we want to. Now I'm going to use the tools that came with the printer, which are not the best tools for doing this, but they will work. And one of these came with the printer, which fits the nozzle here. Now there is, on this printer, not on every printer, but on this one, there is a little silicone sock. Let me see if I can pull it off of there. This guy that is around there, it's actually really hot right now. It does, let me kind of move it off camera. There it is. Right there. It's just a little silicone molded sock that goes over the heater block. So the little aluminum heater block, you can't really see, it's up in here, but it goes over that and keeps some of the heat away from all the other stuff like fan ducts that might be around there. So it's just kind of in the way. You probably don't have to remove it, but I did. All right, now the little wrench, the nozzle should have facets on it that are we heated up? Yes, we're heated up, and now we should be able to grab in there, and you don't want to apply too much force without backup. All right, so it wasn't terribly tight. If it ends up to where it's really, really tight, you really should hold the heater block with a pair of pliers so that you can hold the heater block in place and turn the nozzle. So now it's super hot, obviously, so we're just gonna try, even it's heating up the wrench as I turn it. At this point we could turn the heating off if we really wanted to, or we could get a better tool, but we're just using what we got. They do make little kind of like miniature lug wrenches that fit a variety of these size nozzles, and they work a little better. So there's the nozzle. Now we're pretending this is clogged, which it actually might be now that I've taken it out with filament inside there. And so if we had already done a cold pull and pulled out everything we could, we got this stuff out and it just wasn't working the way we wanted, then what we can do is take this clip out, if you have it installed, so that we can actually shove the tube itself all the way through. So let's see if we can do that. There we go. And see, it will come out all the way out. Whoops, went too far. Actually, you can't see it there because it's in front of, there it is. So it will go all the way through, and you can push everything in there out of the nozzle. Now you don't want to leave it there too long because it's in the heater block, and so it's getting hot. And then we can pull it out, and you know, this has got melted filament in there. We can retract some of that a little bit just so it's not right up against it. You can inspect this thing over time. The end of this tube will, now this brown is from the filament that's in there that we just shoved everything through, but eventually this section is going to get worn. It's going to get, it'll look a little melted and burnt possibly. Just particularly if you print hotter temperature materials, like maybe PETG, that's really at the, would print better at the upper end of what this Teflon can survive. So you might check this and see if it looks okay, or still looks okay. Although I did buy this, so we might as well replace this while we're here. Well, I don't know if we want to just yet because I need to find my tubing cutter. I think I know where it's at. If I can find it really quick, we'll do it. But I got some Capricorn Tubing. So this is, I don't know if you even want to call it special tubing, but it is at least sold as having a more close fit with your 1.75 millimeter tubing or filament, and more uniform diameter. It's got a little bit thicker wall thickness here versus the stock stuff. Same outer diameter and same inner diameter, but a little bit tighter fit to your filament. Now some people actually have trouble with the tighter fit on the filament running through the Capricorn Bowden tube. This is too much drag, and it doesn't actually want to, your extruder doesn't want to push the filament through a long length of tubing. Now we don't have a very long length of tubing here, and we've got a pretty good grip on our filament when it's coming through the extruder, you know, up in this, well, you can't see it's off the screen right now. Maybe if I zoomed, are we zoomed in? Nope. Well, it's off the screen. So I think we should be okay. We'll give it a try and see. It's not going to be a big deal, although it does have a little bit higher melting temperature than this material. At least it supposedly does. I've never actually tested if it melts at a higher temperature. See our nozzle here. Now, I let the filament cool in here, so now this has kind of got a clog in it. So now we have a clog to deal with, clogged up filament in here. Now, when I screw it back in, it's going to melt. We should be able to do a cold pull pretty easy and pull anything out of there. But if the cold pulls don't work, just remember, you can, on an Ender 3 anyway, you can actually take this and run it all the way through and out where the nozzle would come out at, and literally shove all of whatever might be in there, in that body, shove it all out the bottom. So that's what I did to get all of the remaining silver filament out when I had that clog. Let's see if I can find my tubing cutter, and if I can, then we'll chop this and put it in place here. You can cut it with an X-Acto or something like that. You just really want to be sure that these ends are really squared off. Like that one looked a little bit crooked to me. This one looks pretty square because it's going to ride right against here, and if it are, yeah, right against basically these threads on the Ender 3. Other models are going to have different places where this seats in, and some don't even have a Bowden tube. But if it's got a gap in there, like say it was cut crooked and there's a gap, then this is molten filament that's going to come out of that gap and wreak havoc on your printing. You're going to get clogs constantly. So you really want to make sure that this is square with the end of here so that there's no gap when you go to assemble everything. Let's see if I can find it real quick. Well, it wasn't where I thought it was, so I'll have to search for it, and I don't want to spend a bunch of time searching for it. Let's get this thing put back together. Now, the heater block is still really hot, and you can start assembling these with it cold. Obviously, you can just screw the things together, but then you need to heat them back up and do that last quarter turn, of the wrench, quarter turn, to really get it to seat in there without leaks. If you get this too loose in the heater block, if you get the nozzle too loose in the heater block and don't heat seat it in there, then you're going to have a decent chance of having filament coming out around the threads and ganging up all around out here, and it just makes a big giant mess. Now, it is still hot, and so I can't touch it for very long, but we made it. And now we can tighten this thing back up. And again, you really should hold the heater block with a pair of pliers to to make sure that you're not going to twist it off. Remember, maybe you don't remember. I don't know if we showed the pictures or took one apart. Yeah, we did. The very first day, maybe, we took one apart. Remember that there is a tiny, well, not tiny, but a thin heat break between the heater block and the colder side, you know, the side that's being cooled of your hot end. And it's very thin wall. And if you apply too much torsion here, you're very likely to shear that thing off. So that's why you want to hold the heater block if you can, even though I didn't. You want to hold the heater block as you're tightening and loosening the nozzle. Otherwise, you do stand a chance of shearing that heat break. I think actually maybe on Friday or soon anyway, I'm planning on doing a thermal simulation of this so we can see all the parts and see where the heat is generated and where it flows to, what the cooling fan is doing on the cold side of the hot end to keep it relatively cold. You can actually touch all the, if it wasn't covered, you could touch the cold side even though this part is 200 degrees Celsius. If your fan is working correctly. All right, now let's get back down. It keeps getting out of focus on me, which is annoying. I guess it's too many other things for it to focus on, but we want to focus on this guy. So we got to get this tube back into the nozzle seated. Now in this case, you can kind of see where it's been ending up. There's a line right there of just kind of built up gunk. And so I kind of have an idea of how far it's going to go into there, but you have to shove this in until you are certain that that gap between the nozzle and the tube is closed up. And don't halfway put it in there. Remember, if you need to pull it out, you actually have to push this collar. You have to push this collar down to be able to pull that out. That's the way these work. They let it go in one direction, but coming out the other direction will not happen without pushing this collar down. And you want to replace this so it doesn't accidentally work its way out somehow. So now we should be able, I'm feeding filament in just kind of manually over here, just to make sure we've got everything. Yeah, all right, so I squirted out a couple of centimeters of filament. So we'll put this Capricorn tubing on. I also got some stiffer bed springs that we'll work on. Not today. Those are for later. We do need to put, we don't have to, but it's nice to put this back on. For one thing, this is an insulator, so it does keep the heat not only away from your other parts, but into the heater block. So your heater cartridge inside the heater block doesn't have to work as hard to constantly keep the temperature at 200 or whatever you're printing at. So we do need to get that back on there. Again, everything is really kind of toasty right now, so you have to be a little careful. Actually, a lot careful. It's too low for me to see what's going on. Alright, let's see. I suppose we could turn this off and let it cool down and then just put it back on there. But we got it back on. Alright. So now we should be, oh, we didn't put our fan duct back on either. Again, you might not even have to take the fan duct off if you're with the stock set up there. But that's one way on, if everything else is failing, that's the next thing to try. The cold pull will often work. In this case, it just didn't. There was too big a difference between the silver filament that was stuck in there and the brown filament that I wanted to print with next, temperature wise, and I never could get the brown filament to work its way through to heat up the temperature that the silver needed to melt at was way above what the brown was capable of handling. Once the brown got to that temperature, it basically just liquefied and couldn't really push anything out. So it didn't literally liquefy, but it was too soft to push anything out, and it just kept clogging. So we had so the cold pull kind of worked. You know, it did get this nasty stuff out. It got a lot of the stuff out of there, but it's not too terribly difficult. It took us 20 minutes to walk through the whole process of clearing that nozzle out. But on the Ender 3 anyway, where you have a solid throat here that is all of the same diameter, you can literally push the Bowden tube all the way through, and it will scrape the insides and push everything out of there, and that'll usually clear up clogs. Now at some point we are going to need to replace that nozzle. They don't last forever. The brass ones are super cheap. Maybe you just want to replace one because you want to print with a larger or smaller diameter nozzle, and that's fine. Maybe we'll do that shortly. I think I have some other size nozzles here. And it came with one replacement nozzle anyway. So back to the cold pull, that's the first thing to try. And that is where you go to the menu, heat up your nozzle to 200 or whatever's the normal printing temperature for your filament that's in there, or the filament that's stuck in there. Like maybe you changed filaments or whatever. And then once it gets up to that temperature, you go back to your menu and set the nozzle temperature to about 90 degrees Celsius. And when it gets down to 90, you come from this side, you just take the little clip out and pull everything out. If you do it fast enough with a good enough seal, it'll actually pop when it comes out of there. And it will give you something like this, where you've got the shape of that nozzle coming out, and hopefully a bunch of gunk like this that's stuck on everything. And a lot of times that will work. It's the first thing to try if you have a clogged nozzle. Second thing to try is the pushing the tube all the way through. If neither of those work, that's when you have to start taking things apart and disassemble the hot end itself. You rarely actually have to do that. Usually if it's at that stage, then the nozzle itself has a problem, and you just need to replace the nozzle. Anyway, just thought, since I had experienced a clog, it might have been one time that you would also. Doesn't really have anything to do with finishing parts, but it does have to do with printing parts that you want to finish. The other thing, remember I printed the little, I don't have him out here right now, but the little mummy, and I told you he broke off like at his ankles when they printed. And that was when I was removing the support material. So I went in, I printed another guy. It's not a mummy, he's a little orc guy. And I figured I was going to have the same problem with him, so I enabled a different type of support. Now this is not one of his supports. Let's bring you back over here, but it's one of the supports on another model that got printed right here. So this one was actually part of the support system for holding the whoops, where are we at? I think we're upside down now, so I'll have to fix it in a second. It'll work for what you need to see. This was a piece of the support material for one of these blocks here, one of these angles. But on the top here, what I did is I enabled the roof support in Cura. So let me go to Cura. I think I have Cura open already. Yes, I do for once. Let's see if we can find Cura on our screen. There it is. And there he is still. So I enabled in supports. I've got a lot more options here that I didn't have before. These are, so if you go, normally I think it just says generate support, has a check, and then it has support placement everywhere. And I think that's it. I think that's the default, is just those two. It might have the angle, but I don't even know if it has that as the default. I don't remember which ones are default now. But if you go to these little gear icon, it will show you all of the options that you can have that have to do with support. And there's like, I don't even know how many, a bunch of them. And the ones I enabled were, well, I put the support interface extruder, but that doesn't really do anything. Support placement, we already had that with the everywhere versus build plate. Overhang angle, I don't remember if that was default or not, but I did turn it on so that you can Maybe your printer is really good at printing overhangs at a certain degree, and you can specify what that degree is. But where's the one I'm actually, here we go. Support or enable support interface. And it has a roof and a floor. And I put both of them on there. I don't usually use the floor, but the roof is pretty useful. So what this does is, in fact, the floor is not enabled here. What it does is it builds a little roof on top of the support versus just having the support. You can't really see, but inside there's a series of rows of support material. The roof will build a roof on top of the support columns as they print, and that is much easier to remove from your model. At least for me, it's much easier to remove this roof versus the support itself without the roof on it. So if you're having trouble removing support material from your models, try that. Try adding the support roof right here. Well, you enable the support interface, and that will let you enable the roof and the floor if you want to. I just normally, the floor is the same thing but on the bottom, and normally that's printing on the bed itself, or it's not something that I'm really worried about. I just let it print on the surface of the bed. Now if you have a lot, like right here, you know, it has one, get off of there, has one piece of support that ends up touching his leg to his chin, so maybe it wouldn't have helped, although that one didn't really create any problems. You can do support density. Maybe your supports are too dense. In fact, I think mine still are. These are pretty dense supports. You can do that. There are different types of supports. In the experimental setup, there's this thing called tree support, where the default support is kind of these columns of material. The tree literally looks like a bunch of branches going up to support different points on your model. It's in the experimental section still, although it's been in Cura for quite a while. And it's another way. Let me just go ahead and slice it so you can see what it looks like. It looks very different. Oh, no, it's going to take longer to slice because of the trees. Also, this guy is sliced at 0.1 millimeters. That's about the limit as how thin the layers can go. With the 0.4 millimeter nozzle, the stock nozzle on the Ender 3. So he is like 480 layers or something tall. So it did take, when I printed this one, it did take close to 3 hours or more to print just one little guy. But now it's taking even longer to slice because it's having to figure out these tree supports. I just wanted to show you what they look like. It's almost done though. All right, let's see. So see, it kind of has these vine type things going around. It actually is still a lot of the regular support, but there are a couple of places where you can kind of see the tree support. And you can go in and modify a lot of the different options on that. I actually think that if you're going to use tree support, you might be better off putting those in a different slicer and just saving them as part of the model. Maybe going into Mesh Mixer and using its tree support. They're much easier to deal with than the ones here. You can go in and manually reposition them very easily in Mesh Mixer. All right. Let's see. What else did I want to talk about this guy? Oh, another thing just on this guy. Since he's got a lot of details on the front, if I tilted him standing upright, some of these would have support. In fact, there was a little support on his chin. So I tilted him backwards a little bit so that where he was interfacing with support, it was kind of on his back and it didn't matter as much. So that's a little thing you can do, is you can reorient these things not just 90 degrees but any angle you want with the little gizmo here. You can tilt them however you want to, and a lot of times maybe it's easier if you know that you're gonna have to deal with supports anyway. It might be simpler to put them in places where they're not as obvious. This model error didn't affect anything. It means that there's a hole in this model somewhere. We had that same thing with the mummy and it wouldn't slice, but I didn't actually have to fix it. Cura was able to deal with it, although you could take it into Mesh Mixer and repair the model there. I didn't want to bother trying to do all that, so I just sliced it and printed it here. All right. Let's talk about, I think that's all of the things that I wanted to talk about that weren't finishing. So today what I thought is we're just going to have to go and get a beginning to all of these finishing things. I'm going to show you some supplies you might use. You don't have to. Oh, there's the one thing I was thinking of while it's up on the screen. I thought maybe we would do something like this. It has a lot of different techniques, maybe a metal finish, some weathering, a wood finish. Maybe that would be our project for different, showing how to finish different things. This is Han Solo's blaster from the first in release order Star Wars film. But if you have a better idea of a different project, let me know, and we can work on different things. Doesn't matter. This is just the one I was looking at that I thought of that I knew there were files already created. We didn't have to go make files to find the STLs for this. So there's already several. Actually, this is just a stand here. So actually, I need to find the actual. This is just a stand. We don't want to print just a stand. But this might be a good one to show off of various types of finishing things. Anyway, that's not what I was trying to do. I was trying to go to our other screen, which I think is here. No. Oh, wow. How many of these do I have turned on? Not that one. Not that one. There's another one. There we go. All right. So, usually what I use are a combination of things depending on what I'm trying to accomplish. So I'm going to, there you can spend any amount of money you want to on tools and equipment and supplies for finishing 3D prints or whatever. So I'm going to start with stuff that's relatively simple and not super complicated or expensive. But a lot of times what I'll do is like for this guy. If I was going to work on this guy, then what I would do with him is I would sand him a little, but he's so tiny that you're not going to be able to sand a whole lot. But there are things like these little hairs that are coming off here. Sometimes, particularly if your retraction settings are not so great, maybe you haven't got those dialed in yet, or maybe whatever went wrong and he's really stringy. Sometimes you can just hit those with a hair dryer and they'll basically shrivel up and vanish. They don't actually disappear, but they'll kind of suck up into the model itself. And I might try that on this guy to get some of those smaller ones out of there. Otherwise, you need to go in and pick them out, something with tweezers, which can be tedious. Now this guy doesn't have that many on there, but get all that kind of stuff off. I already removed the support from him. I don't even have it anymore. It was just, I basically took these, which were off the screen, these nippers, and cut most of the supports off. I did have the roofs enabled here, so it was simpler. It was still a little bit difficult. There is a setting in Cura also that defines the distance between your support material and the model. And so this model was printing at a 0.1 layer height, so the layers were 0.1 millimeters tall, and that kind of shrunk the distance also between the support and the model. And it was a little bit difficult, but it wasn't horrible. It didn't just fall off of there, but it didn't break anything. He's got little tiny thumbs sticking out here. It didn't break that off. You can kind of see a little bit of remnants of the support there. Maybe right there, there's a little bit of support left, but it's overall not bad at all for a print off of a basically stock. The only thing that I have on here that affects the printing is that little red fan duct. Everything else that I've put on the printer doesn't actually affect the printing at all. Maybe when we put this on here, it'll affect it a little bit. Not really. When we put the stiffer bed springs on, that'll just be more to keep it level and have a little bit less chance of vibrating, although we're not particularly printing super fast speeds anyway, so it's not gonna the bed's not gonna just bounce around too bad. And I've got the springs that are on there tightened down pretty much as tight as they'll go, so it's almost a solid bed mount anyway. These will just make it a little bit stiffer. And remember, we did look at maybe just making them solid to begin with. But none of these directly affect the printing. We haven't changed the nozzle. We haven't changed the hot end. We haven't changed the extruder. We put the different extruder handle on there, but that was just to prevent future issues if the plastic one were to break. It doesn't actually change anything. So on a stock Ender 3, you can print pretty detailed stuff. Now, once I put some primer on here, that would be the next step. So I'd clean him off, and then I would probably, this is not a totally necessary step, but I would probably spray him with this adhesion promoter. So this is specifically made for, well, automotive plastics. But that's mainly because I bought it at an auto supply store. I assume it doesn't necessarily have to be automotive plastics. It's just sold and marketed to that particular group. But it's a primer. It doesn't show up anything. It's not gray or red. It's just clear, clear primer. But it's an adhesion promoter. And since we're trying to stick stuff directly to plastic that has just come out of an extruder, it's kind of melted and everything, then I usually spray them with that. Again, that part's probably optional, and it probably doesn't make much difference at all. But I do that just to have the next step have a better chance of sticking. And then the next step can either be go straight with some paint. Spray paint is what I would use next, or an actual coat of primer. And there's two coats of primer that I like to use. One of them is something like this. So a Sandable primer. So this one, the ones that are Sandable, they generally, or the ones that particularly say Sandable, they'll say something like high build or Sandable or something like that. And what that indicates is that they're pretty thick, and they're gonna fill in gaps, and not necessarily gaps, but they'll fill in unevenness in your model. Now, that may not be what you want on something with a lot of detail that you want to retain, because it might wash out a lot of the detail. Like on his face, it might just end up filling in his eye sockets and everything. But on something that is larger, maybe it's like that if we did the DL44 model, I'd probably coat it with this stuff to try and even it out, because it's supposed to have a flat metal finish on it. And so I'd probably use that. If I'm trying to retain the detail, then I'm probably going to use something like this. So this one is a Model Master. I got it from Hobby Lobby, probably. Yes. Kind of want to use your coupon though, because it's $6 for a little tiny can. Although you don't use a lot of it, and so this can I probably bought a year ago or so. But these are a little bit thinner, and you can spray them on. You can spray anything on thinner just by moving the can farther away from what you're aiming at. But it's formulated to be thinner also, and so you won't lose as much of the detail. There's some other companies that make similar things to this that are even finer, but they cost even more. So I usually use something like that on a model like this. So that's probably what I'll do. I'll probably spray this guy with the adhesion promoter just to put it on there. And that does take up some space, so you can't like go too heavy with any of these coats or on something that you want to retain the detail. And then I'll probably spray them with this. This comes in different colors. This particular one's white. Once you put that on, then you have a good idea of what you're looking at as far as layer lines go. Some people would sand first. Now this guy's really hard to sand. What I'm going to go to do is I'm going to use these. Like this is a round file and a square file, and they're on the smaller side of files, and you can get in there, and if you see any obvious places where there's little pieces left, you can file them off of there. Now PLA, this is PLA. PLA is not friendly to sanding. Other materials are much easier to sand. ABS is way easier to sand, but it's harder to print. And you kind of have to have or it's best if you have an enclosed printer, like a box around it of some sort. It prints at hotter temperatures, so it's just a little bit harder to deal with ABS. But once you've got it printed, then it's much simpler to deal with in PLA. PLA is on the more rigid side, I suppose, and so it's harder to sand the PLA surface. So it's, for me, instead of sanding first, I'll go in and clean up the big details with one of these files, or maybe even if I have to cut something off, a set of nippers like this. So these are one-sided, really sharp nippers for cutting. I actually think they came with the printer. I think these, or one like these, came with the printer for cutting the filament. But they're really good for cutting off tiny little pieces that you're trying to sand off. But I won't do a whole lot of like sandpaper sanding on something this size and in PLA, just because it's so hard to sand. Now, if we do that blaster, Han Solo's blaster, well, we will do some sanding just to try and even out the layers before we do the next step, but I also won't print it at 0.1 millimeter layer thickness. I might print it at 0.28 or certainly 0.2, and there'll be much thicker layers. This one does have pretty thin layers, although they're going to show up when we put any kind of flat color on it. We're going to see those layers, probably. But that's the thing. I'll have to do those steps and bring it back next time. Other things, let's say the next thing wouldn't really work for something this size. It would be for more like the blaster. You have materials like this. I have to zoom out to get that in there. Products like this. So this one, I don't remember how much this cost. Doesn't have a price tag on it. I think I ordered it online. But this is basically a resin that two-part resin. So there's two bottles in here that you can paint onto the model, and it doesn't deform the model at all. It basically coats the model with a thick resin, and so it will lose a lot of the detail. Like if I put that on this guy, he would just he would have his overall shape, but any of the little tiny details would just be totally gone, because this is a pretty thick resin that you're putting on there. It's similar, if you've ever worked with fiberglass, it's similar to the fiberglass resin without the actual fiberglass in it. So it's similar to that kind of thing. And so you paint it on. It will self-level to a degree depending on the size of the surface you're putting it on. It will be a little bit wavy if you tried to put this on something that's supposed to be perfectly flat. It will be a little bit wavy. But the good thing is that once it's hardened, which takes, I don't know, a couple of hours, I think. It doesn't say right on here exactly how long. I assume if I opened it open. Actually, it says, oh no, that's if you got it in your eye. Never mind. I don't know, a couple of hours it's going to dry. And then it is really easy to sand. So it is a good finish to basically encapsulate the print and then sand this, and this is your surface. And it is much simpler to sand. So there are products like this. This is the only one I know that's specifically for 3D printing. But it's basically just a resin, a two-part resin that you could get other brands of that are doing the same thing, basically. There's nothing particularly special about this one other than it's not going to melt the PLA or the ABS. A lot of these resins, as they cure, they get hot. They're exothermic reactions when they're curing. And so some of them might get hot enough to deform, particularly PLA, because it'll start to deform at a relatively low temperature. This one won't deform PLA. It even says it can work for all these different things. Some of the others are foam and plaster and fabric. So it's not specifically just for 3D printing, but this version of the product is formulated and marketed for smoothing out 3D prints. You might have heard of some people taking acetone and vapor smoothing, or maybe dipping into acetone to smooth prints. That doesn't work with PLA. It will work with ABS. It works really great for ABS, but for PLA, it doesn't really do anything. Eventually, it will cause the PLA to basically break, melt in a way that's not at all what you were hoping for. So don't try the acetone smoothing with PLA prints. It's not going to do, I've never seen it do anything useful. That's more for an ABS type print. And even then, it's a little bit dangerous because the acetone vapor is super flammable. So you have to be very careful with where this is going on at. There is, not for any PLA, but there is a PLA product that will smooth with hydrogen peroxide. I do have one of those. It's not here. It's back at my office. So I might bring that out, but you have to print with a particular blend of PLA. And it does a similar thing. The problem with both of those, acetone smoothing and the hydrogen peroxide smoothing with the special PLA, is that you're going to lose a lot of the details. So if something like this, it's going to end up very blobby and not very highly detailed. So it's not a great option for details. But if it's a larger print or something that's supposed to be kind of rounded and smooth, then those are good options for that. All right, I think what we're going to do is each time I'll spend a few minutes updating where we are on different techniques. So the next thing that's going to happen to this guy is I'm going to spray him, and maybe I can take some videos and put them up separate but not live. Spray him with the adhesion promoter, spray him with this white primer, and see where he's at then. Actually, before I do either of those, I'll go back through and use these tiny little files to clean up any spots that look like they need cleaning up. And then the next time you see him, he'll be coated with this guy, and then we'll see what we should do next. Other things I plan to do with the finishing series, there's a lot of different things other than just painting. You can hydro dip parts. You can actually make parts look metallic. There's a couple of different ways to do that other than just spray them with a spray paint that has a chrome cap on it. That kind of works, but not that well. There are much better ways to make like a chrome finish or a metal finish, and we'll do some of that. Particularly if we do the DL44 or something like that, maybe a lightsaber, I don't know. They don't have to be stuff from Star Wars. I guess that's just what I'm thinking of right now. There are a lot of different painting techniques. You can actually electroplate plastic. It's a process where you use chemical solutions with suspended metal in them, and they can deposit the metal on the part. It's not quite that simple, and they're generally not particularly cheap. Like the cheapest ones, you're going to be $100 in by the time you have the right power supply and the right chemicals and the right equipment and the right setup. So it's not a particularly cheap way to go about doing it. There's a lot of painting techniques that we'll look at some of those just to get the final thing to look more like what it is you're after. If you're after metal, or if you're after wood, or if you're after a used part versus a new part, or things like that. So let me know if you like the idea of the blaster being our test case, or if you have something else that sounds like it'd be a better test case. Let me know. I'm not particularly sold on any one of them. I haven't printed any parts for anything yet, so we're not losing any time by changing up now. So let me know if you would rather see something else. I'm looking at my notes here to see if there's some other things I needed to say. I think not yet. So the next time you see him, he'll be painted. Well, actually, next time we'll start with him, spend a few minutes on where he's at on the finishing, and then we'll move into setting up Octoprint, because that's the main focus for next time is Octoprint. This one was supposed to be mainly finishing, but I kind of, since I had a clog, I figured that I wanted to go ahead and tell you how to get rid of those in case you also had a clog at some point soon. I think this is probably a good stopping point because there's not a lot I can do on him other than I can go spray him, but I can't take you with me out there. I don't want to spray him inside. I want to spray him outside. So I'll bring him back next time. He'll look a little different, and we'll see what to do with him from that point. And then we'll set up Octoprint, or at least start setting up Octoprint. Hopefully we'll get it finished. And then we'll move into Friday. I think maybe that's the thermal analysis of the hot end is what we're doing. I'll have to see. Anyway, those are kind of the plans for where we're headed. Let me know if you have some ideas on other things we can print and finish, and we'll see what we can do. I'll see y'all on Wednesday.